Hi, in this video we're going to continue talking about Python. So, Python was designed to be a highly extendable via models. This compact modularity has made it particularly popular as a means of adding programmable interfaces to existing applications. Van Rossum's vision of a small core language with a large standard library and easily extensible interpreter stemmed from his functions with ABC, which espoused the opposite approach. Python strives for a simpler, less cluttered syntax and grammar while giving developers a choice in their coding methodology. In contrast to Perl's there is more than one way to do it motto, Python embraces a there should be one and preferably only one obvious way to do it philosophy. Alex Martelly, a fellow at the Python Software Foundations and Python book author, wrote, to describe something as clever is not considered a compliment in the Python culture. Python's developers strive to avoid premature optimization. What is premature optimizations? Optimization can reduce readability and add core that is used only to improve their performance. This may complicate programs or systems, making them harder to maintain and debug. As a result, optimization or performance tuning is often performed at the end of development stage. Donald Knaus made the following two statements on optimization. We should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet we should not pass up our opportunities in that critical 3%. He also attributed the quote to Tony Howard several years later. Also, this might have been an error, as Howard claims, having coined the phrase. In established engineering, describes a 12% improvement easily obtained is never considered marginal, and I believe the same viewpoint should prevail in software engineering. Premature optimization is a phrase used to describe a situation where a programmer lets performance considerations affect the design of a piece of code. This can result in a design that is not as clean as it could have been or code that is incorrect. Because the code is complicated by the optimization and the programmer is distracted by optimizing when deciding whether to optimize a specific part of the program. Amdachel's law should always be considered. The impact of on the overall program depends very much on how much time is actually spent in that specific part, which is not always clear from looking at the code without a performance analysis. A better approach is therefore to design first code from the design and then profile benchmark the resulting code to see which parts should be optimized. A simple and elegant design is often easier to optimize at this stage. and profiling may reveal unaccepted performance problems that would not have been addressed by premature optimization. In practice, it is often necessary to keep performance goals in mind when first designing software, but the programmer balances the goal of design and optimizations. In practice, it is often necessary to keep performance goals in mind when first designing software, but the programmer balances the goal to design and of design and optimization. Modern compilers and operating systems are so efficient that the intended performance increases often fail to materialize. As an example, catching data at the application level that is again cached at the operating system level does not yield improvements in execution. Even so, it is a rare case when the programmer will remove failed optimizations from production code. It is also true that advances in hardware will more often than not obviate any potential improvements. Yet, the obscuring code will persist into the future long after its purpose had been negated. Um, Python is meant to be a easily readable language. Its forming is uncluttered and often uses English keywords, where other languages use punctual. Unlike many other languages, it does not use curly brackets to delimit blocks, and semicolons colons after statements are allowed but rarely used. It has never syntaxes, exceptions, and special cases than C or Pascal. Indentation. Uh, Python uses white space indentation rather than curly brackets or keywords to delimit blocks. An increase in indentation comes after certain statements. A decrease in indentation signifies the end of the current block. Thus, the program's visual structure accurately represents its semantic structure. This feature is sometimes termed the offside rule. Some other languages use indentation this way, but in most indentation has no semantic meaning. The recommended indent size is 4 spaces. Statements and control flow. The assignment statement using a single equals sign. The if statement, which conditionally accesses a block of code along the else and elif, a contraction of else if. So that's all for now. Thanks for your view. Waiting for you in my another video. You should leave your comment and put the like. So thanks for your view. Have a nice day. Bye.